Douglas. I think the other one was a better one. Cobb Douglas utility. And this is u of x1, x2 equals x1 to the a, x2 to the b. Okay? A and b are known. Like in our example, it was half and 1. Now I take budget line is P1x1 plus P2x2 equals M. M is the income. So I can tell you this is the income and these are the prices. P1, P2 and M are known. Question: what is the optimal bundle that the consumer can afford? When I say the consumer, I mean the one that has the income M and faces utility x1 to the A, x2 to the B. So first of all, as before, this will be a repetition, but it's important to remember. So I have, this is x1, this is x2, this is the budget line, so this is M over P1, this is M over P2, and the slope equals negative P1 over P2. Again, the minus P1 over P2 is just to say that if I want to increase my bundle by 1 unit, by how much I have to give up on how many units I have to give up on x2, it is P1 over P2. Okay, now whatever, I mean, this one, if you look on the indifference curves, they look like they have this shape. By the way, let's confirm it. Let's say that I want to find out when the utility equals 1. U equals 1, U equals 2, or 3, or 4, all of them will be very similar. This is when x1a, x2b equals 1. So when this is when this means that x2b equals 1 over x to the a, and x2 equals 1 over xa divided by b. You take the power 1 over b in both of them, you get exactly this. Now, like y equals 1 over x, or x to the power 5 or 3. How it looks like? It looks like exactly something like this. And instead of 1, if you put in 5, you get 5, but look, what happens is this. When x is very, very big, 1 over a big number becomes very close to 0. Never touches 0, but close to 0. And when x is very close to x1, so. And when x1, this is x1 and this is x2. And when x1 is very close to 0, you have 1 over something which is very close to 0, then it goes up and up to infinity. So it's exactly looks like this. So actually I'm looking, so there are many, many different scales, but I'm interested in the one that just tangent to the budget line, or the budget line is tangent to this indifference scale, and I ask myself, what is this? What is the utility, which is not that important, rather what is this, let's call it x star. X star is x1 star, x2 star is a bundle. And that's what I want to find out. Remember, what are the parameters that I know? I know A, I know B, I know M, I know P1, and I know P2. These are given. I know, right? I know what is my income. I know what is the market price. I just go in the market and find out the price. I know what is the market price of 2. And I know my utility. That's an assumption. I know my utility. Knowing my utility, I have to know A and B. Okay. So now the question is, what is X star, the optimal bundle? So again, first I want to say the following. What is the property of X star? So first of all, X star is on the indifference scale. Its MRS equals du, maybe I write it first as mu minus of minus of mu1 over mu2 at x star, because the MRS changes, okay? But I can say that's what we did last time, and remember, MRS at x star is the slope of the line. By the way, can we see it? Is the slope of the line which tangent to IC at x star. So forget about, suppose I don't know that this is a budget line with the prices and stuff like this. I just want to find what is the MRS of x star. What is it? I have to take at x star a tangent line, okay, and the slope of the tangent line is the MRS. So the MRS is the slope of the line which tangent to IC, to the indifference scale, at this point. It so happened that this line, this tangent line, is the budget line. But this tangent line, in our case, is the budget line. What does it mean, the budget line? P1 x1 plus P2 x2 equals m. Great. So I know what is the slope, and its slope equal negative P1 over P2. That's what we wrote here. Very good. So actually the first equation, I know the utility, so I know marginal utility of U1 and U2. I'll divide one by the other, and I'll set it up to be equal to negative P1 minus P2. So my next question is, what is MU1 and MU2? Let's compute it. MU1 is du to dx1. So I look on our function. If I take a derivative with respect to x1, x2 is held constant. So I multiply by this. But what is the derivative of this? I take the a out, and here I have the power is a minus 1. So I can say this is x a minus 1 times x2 x1. x2 to be. I take the a out and I have to subtract 1 here. That is a constant for me. Now I do the same thing for MU2. mu2 is du to dx2. So I take x1 as fixed, and I take the derivative of this is b times x2 to the b minus, to the power b minus 1, times this. So I can write it like this, b x1 to the a, x2, b minus 1. Simply, I took the derivative of mu with respect to x1 and with respect to x2. Now I have to divide the two, because the MRS, so MRS at x, in general x, is negative the ratio. So it's a x1, a to the minus 1, x2, b, divided by b x1, a, x2, b minus 1. So I can write it in a way, look, what is x1, a minus 1 divided by x1, a? This has one more than this. So actually, this will be divided, that this over this is 1 over x1 to the power a. Okay, what is x1 to the 7, let's say a is 8, to x1 to the 8 is 1 over x1. So I can say that this is actually a over b. This over this, I have to put x1 down. But this over this is exactly x2, because here I have 8 over 7, so x2 to the power 8 over x2 to the power 7 is x2. So I got the MRS and it's a minus. MRS is a very simple expression. And now I know that this is equal to the slope of the budget line. Okay? And its slope is this is the slope. So now I have to compare this to this, I mean to equate. So I'm getting that negative a over b x2 over x1 equals negative p1 over p2. We take the minus out, and I can write down how x1 relates to x2, or what is x2 with respect to x1, it doesn't matter. So if I multiply everything by b times x1, I will get, so I multiply by this, it goes, I get that ax2 equals b p1 over times x1 over p2. So from here I know what is x2, I divide by a. So x2 equals b over a, p1 over p2, x1. So the relationship of this point x star that I'm looking, the x2 of the optimal point must be b over a, I know this, times p1 over p2, I know this, this is some number, 5, I don't know, times x1. So there is a linear relationship between x2 and x1. x2 is a constant times x1. I'll continue here. I have the slope, everything, so let me continue here. So I plug this, I substitute this into the budget line. P1x1 plus P2x2 equals m. But I know what is x2, it's this one. So I'm writing P1x1 plus P2. Instead of writing x2, I'm writing b over a, P1 over P2, x1 equals m. Remember, this is our x2. Now I have one equation with one unknown, and actually B, A, and P1, P2 are all fixed. So I can find what is x1. So let me write it down. So, by the way, the P2 and P2 I can cancel. I can, in that case, I get x1, and here I have P1 plus BP1 over A. You see, x1 I have B over A P1, and here P1 equals M. Okay? So actually I have AP1 plus BP1. So let me write it down. This is, just this part, is AP1 plus BP1 divided by A. So I can write down it's x1 times, this is A plus BP1. A plus BP1 over A equals M. So x1 star equals A over A plus B, okay, times M over P1. And this is the optimal x1 star. We found this much. Now we want to find x2 star. But x2, we know, we found what is x2, this is x2. Okay? This is x2. Actually, it's written there. So now I have to substitute. It's not a big deal to find out what is this x2. So x2 star is what? It is B over A times P1 over P2 times x1, but x1 is A over A plus B times M over P1. So first of all, this and this goes, and x2 star equals B over A plus B times M over P2. We found it. By the way, we can find also what is the utility level. Not that it is very important, but just maybe of some interest. So now I want to find the utility function, the utility level, sorry, and I want to give you explanation. What does it mean? This x1 star and this x2 star. In a few minutes, you'll get everything. So first of all, if I want to find the utility level is actually, the utility level of this is x1 of x1 star, comma x2 star. It is x1 star to the A, x2 star to the B. So I have to multiply all of them. So here I have to the power A, so I have A over A plus B to the A, M to the A, P1 to the A. I take all this to the A and this to the B, times B over A plus B to the B, and M to the B, and P2 to the B. So, I mean, you can compute and find out what is it, but this is, if you like, the A plus B has power A and has power B, so it has, so this is A to the A times B to the B over A plus B to A plus B, and here I have M to A plus B, because M to the A times M to the B, and here I have P1A, P2B. By the way, it is not really important, but just as an exercise, I don't care how many U times I'm getting out of it. What I care is, what should I buy? What is x1 and x2 that I should buy? So these are the formulas for them. But now let's look on something very interesting. Let me look, what is P1 x1? What is P1 x1 star plus P2, just P1 x star. So as you can see, P1 x star I multiply from this one. It is A over A plus B times M. Similarly, P2 on x2 star is B over A plus B M. And this has interesting meaning, and let me explain what is it. This is the x1 star is how many units I buy from x1. When I multiply by the price, this is my expenditure just for good number 1. So actually, with this utility, it says that I completely separate my budget M, a proportion A over A plus B of the budget goes to spend on x1, and a proportion B over A plus B of the budget is going to go for the expenditure of x2. So it means that my utility is such that, let's say that my income is $1,000, and I have 2 goods, I don't know, food and entertainment. So it tells me, and my utility function is x1, did I take it out? The utility function is, we're talking about Cobb-Douglas. You know what, let's take first A1 and B1, just as a simple case. So what does it mean? It means that this is half. Let's say A and B are 1. So this is half, this is half. It tells me, if you have a budget of 1,000, spend 500 on food, 500 on the entertainment. Suppose that A is 1 and B is 4. So it will tell me, spend 1 out of 5 of your income. Namely, if my income is 1,000, 1 over 5 is $200 on food, and the rest, 800 number on entertainment. So actually, it makes the solution simple to digest, in a sense, because it tells you you have two goods. You take your money and you are going to split your income into 2 parts, and the proportion of the income that you spend for good 1 is just the proportion of the power A over A plus B. And the proportion of a good 2 is the expenditure of good 2 is the proportion B over A plus B of your income. So you separate your income proportionally to the 2 goods. That's what the Cobb-Douglas say. What is the proportion? Depends on A and B. So if they are the same, A equals B, then always this is going to be half. So you spend the same amount. You split your income half-half for the 2 goods. So this is the Cobb-Douglas utility, the optimal bundle of the Cobb-Douglas utility function. So I gave you a numerical example at the beginning, just to, if I have, so in our case, let's say that A equals B, and we have M equals 100, and P1 equals 2, and P2 equals 1. So according to this, x1 will be A over B, A over the sum, but they are the same. So x1 star will be half half, because A over A plus B, they're the same, is 1/2. And then I have to multiply by the income, 100, over the price P1. What is it? 2, which is 25. And what is X2? X2, and it's again half, B over A plus B, they're the same, is half. So I have 100, half, times 100, divided by 1. So this is 50. So I'll spend on X, the number of units that I'll take to X1 star is 25, and for the number of units of good 2 will be 50, but I'll spend the same amount, because 2 times 25 is 50, 1 times 50 is 50, so I'm going to split even